Hello everyone, welcome back to this channel. Today we are going to continue our collection of ordinary level physics national examination 2019. So last time we collected question number 3 in section A. So today we are going to continue our collection by collecting question number 4. Let us go. Yes, this is question number 4. Say that LRC cell circuit consists of an inductor, resistor, capacitor, and an alternating current generator. Complete each of the following statement with the correct term from the word. Here there is increase, decrease, or remain constant. So write only the answer in our answer booklet without copying a statement. So what we have to do here, we have to read the following statements and we complete them. We have to read them and we complete by word increase, decrease, or remain constant. Yes, let us go for the first statement. Say that if the frequency of alternating current of generator decrease, the reactance offered by capacitor to the alternating current. So here we are going to say where we are going to complete by increase, decrease, or remain constant. So in order to complete this statement, we have to know the relationship between the reactance and frequency. So let us see first the relationship between reactance and frequency. Yes, as you see here, this is LRC series circuit. It means that here there is resistance, there is inductance, and there is capacitance that are inside in cell. So here there is XC. These XC symbolize capacitive reactance. This XC symbolize capacitive reactance. Yes. So and also this F symbolize frequency and this C symbolize capacitance. So what is the capacitive reactance? It can be taken as resistance to the flow of alternating current by a capacitor. Yes, through the formula we see that capacitive reactance is equal to 1 divided by 2 pi frequency capacitance. So as you see, the frequency is on the denominator. This means that frequency is inversely proportional to capacitive reactance. Yes, as the frequency is found here on the denominator, this implies that frequency is inversely proportional to the capacitive reactance. So this means that as the frequency increases, capacitive reactance decreases. So as frequency decreases, capacitive reactance will increase. You can even prove it by using mathematics. Yes, mathematically can be proven. So that's why here we say that according to the formula, the frequency is inversely proportional to the resistance. So as the frequency decreases, reactance will increase. Yes. So we can use what we have seen here to answer our question. Let's go back to the statement. Let's go back to the statement and see what it means. It is saying that if the frequency of alternating current of generator decrease, the frequency is decreasing. You see, the reactance offered by capacitor. This reactance offered by the capacitor, it means it is capacitive reactance to a alternating current. So you're going to see, are we going to put increase, decrease, or remain constant? So as we have seen, remember, we have seen that capacitive reactance is inversely proportional to the frequency. So as the frequency decreases, the reactance will increase. will increase. That's why here we will put increase. Yes, let us go for the second statement. If the frequency of alternating current of generator decrease, the reactance offered by inductor to alternating current, so we are going to see where we are going to put increase, decrease, or remain constant. So here that is the second thing that they have introduced. Remember, for the first question we were dealing with frequency and reactance through capacitor. So here also we are going to deal with the frequency with reactance through inductor. So that's why we are going to see the relationship between the reactance in inductor and the frequency. So let us see the relationship. Yes. So as you see, this XL, which is equal to 2 pi, this is 2 pi frequency L. So we are going to see what is this XL. So this XL actually stands for inductive reactance. This XL stands for inductive reactance. This means that it is reactance through inductor. So is defined as resistance to the flow of alternating current in inductor. Yes. So this F also is, as I have said, this frequency is, this F is standing for frequency, this R is standing for inductance. Yes. So as you see that the reactance in inductor is directly proportional with the frequency. Yes. So you see, as the frequency increase, also the reactance will increase. So as the frequency decrease, the reactance also will decrease. So you see that they are directly proportional. So that's why here we say that it's obvious that frequency is directly proportional to the reactance. So as frequency decrease, reactance also will decrease. So after seeing this relation, this will facilitate us to answer the second question. Let us go and answer it. As you see, let us read this statement. If the frequency of alternating current of a generator decrease, the reactance offered by inductor to the alternating current, so increase, decrease, or remain constant. So we have seen that the frequency is directly proportional to the reactance of inductor. So, and remember, we have said that as the frequency increase, also the reactance will increase. If the frequency decrease, also the reactance will decrease. That's why, to answer our question, if they have said that the frequency here is decreasing, it's obvious that also the reactance also will decrease, as we have seen that the frequency and the reactance, they are directly proportional. Let us go to the next statement. The next statement says that the resistance offered by a resistor to alternating current dash when the frequency of alternating current of generator decrease. We are going to see where here we are going to put increase, decrease, or remain constant. So to know that, we have to know the relationship. We have to know the relationship between resistance of a resistor and frequency. And as you see here, they say that the frequency here will decrease. So we are going to see, is there any relationship between resistance and frequency? So as we see here, we found resistance by respecting Ohm's law. Ohm's law says that the resistance through a circuit is equal to the voltage divided by the current. Yes, so the frequency doesn't affect the resistance of a resistor. Yes, because the resistance remain constant whenever frequency increase or decrease. So you have to know that the frequency only affect the reactance of inductor and reactance of capacitor. So for the resistance of resistor, the frequency doesn't affect anything. That's why the resistance will remain constant. So answering our question, you see that here we'll put remain constant. Yes, we would say that the resistance offered by a resistor to alternating current remain constant when the frequency of alternating current of generator decrease. Thank you very much. Those are the answers for this question. Yes, as you see, the first question was increased, the second was decrease, and C is remain constant. Thank you very much for today, and I think here we have learned many things. We have seen the relationship between capacitive reactance and frequency, and also the relationship between inductive reactance and frequency, and also the relationship between frequency and capacity and the resistance of resistor. So I think it's very understandable. Thank you very much. See you in next video where we are going to collect question number 5. And I would like to tell you that if you didn't subscribe, please subscribe. And if you have something like comment or something that you can improve, please, you're welcome and comment. And also knock the link so that you can get notification at any time. Thank you very much for today.